Welcome to Burlap Teachers. Enjoy the video.
You start by confirming the sensor model and required voltage because mismatched power destroys hardware. Power off the host and use a multimeter to verify supply rails. This prevents accidental shorts. Once done, identify the connector and pinout, V+, GND, SIG, and mark orientation with tape so you don't flip pins. Make the first connection to GND, then V+ briefly to check current draw. This step shows you the sensor is awake before attaching signal lines. Next, route the signal wire to the designated input and keep it separate from noisy power lines. That reduces interference. If the sensor needs a pull-up or pull-down, set that on the microcontroller or use the correct resistor value so readings sit in a defined range. Configure the ADC or digital input for the expected range and sampling rate. This determines accuracy. Once configured, secure every connection with solder or proper crimp and add strain relief to prevent future failures. Finally, power on and watch the sensor's LED or initial waveform to confirm basic operation. A steady idle reading means you're close. Calibrate offset and gain in your software, taking a 10 to 30 second sample so averages remove transient noise. Verify communication packets or ADC values match specs, then fasten the enclosure. If readings are unstable, check ground continuity and cable shielding first. Poor grounding is the most common culprit and often fixes intermittent errors immediately.
Thanks for watching. Consider subscribing if this video helped you.